here at Fruition. And I specialize in matching cloud and DevOps professionals with organizations looking to hire them. So I've got a very strong network in this space. Feel free to drop me a connection on LinkedIn if you want any help or advice. That's Joe Cox. And for those who haven't come across Fruition before, we're a tech recruitment firm based in Leeds. We're very involved in the tech meetup scene. And we just wanted to keep the tech community engaged and give something back in these strange times. So we're putting together a webinar series we've called Lockdown Learning. This is our 9th installment. And obviously a very special hands-on edition. So as Jordan, you can see from the slides there, we've partnered with Sandbox, who've kindly agreed to showcase their learning platform and give you all access to incredible resources, which you'll hear about shortly. So I guess, Jordan, without further ado, over to you.
Thank you very much, Joe, for that intro. I hope we're going to go through this without too many technical difficulties. There's always something playing up. So, hello everyone. My name is Jord. I'm the co-founder and CEO of Sandbox. I will do a very quick background on the company and on why we're building what we're building. And then we'll give it over to my co-founder and CTO and sort of lead developer architect behind MSB, Mislav. And so yeah, let's get started. You're gonna, let me just quickly see. I don't have the chat here in front of me. I think everyone can hear me all right and see me all right. So why do we start MSB? Quick background on the founders, which is myself and Mislav here. We've always been learning a lot, essentially, in our previous jobs and jumping around throughout our career in our early 20s. And we really realized that to get all this learning going, essentially, it really was required at that time to jump from job to job over and over. And what we realized was that with the low infrastructure costs essentially now available, we are actually able to deploy any kind of training on real infrastructure and expose people, especially developers, to these world-class learning environments that only few of us have been exposed to at this point. So essentially, we're trying to blur the lines between the work environment and training, all on real infrastructure. And so what that ultimately means is that MSB essentially is trying to unlock the potential of anyone, irrespective of where you live, where you were born, where you work at the moment. Yeah, we hope you resonate with that message, I should say. So our mission is essentially to enable any software engineer at any company to reach their full potential. And now, sliding into the more Kubernetes DevOps side of things, I would like to give it to Mislav and dive into the content of today's webinar. Now the question is, can we get you to share your screen? So let me know if I can pause my screen share or hand it over to you as the host.
Hi everyone, we're just trying this new webinar. We just changed accounts, so I don't think my video is enabled. Just give me 3 seconds to enable it in the settings and I'll take over.
So I just made you host. You should be able to have sharing access. Let me stop my share.
Okay, hello everyone. I hope everybody can see and hear me well.
Is your right mic on?
Okay, I think this should be better. So I hope everybody can hear and see me well. I have a feeling somebody raised their hand. I think Chris Dunn. Would you like to say something? So yeah, we'll be using the Zoom webinars. I hope you're familiar with how things work here. So basically there are, some people say they cannot hear properly. Is that true?
It's very echoey, very far. Where's your mic? Can you just put it in front of you? Try again.
People are saying they can hear fine. Okay, sorry. So we're using the Zoom webinar. So we have the chat here. If you're using the chat, please use the all panelists and attendees toggle. If you have any questions during my presentation and all of this, please use the Q&A section. So how this usually works is I'll be speaking here and checking open questions every now and then and trying to answer them. We are trying to make this as interactive as possible, so feel free to ask a lot of questions. Otherwise, we would just, send you a video. So I hope you're enjoying what we're gonna do. I think you're let out. Yeah, let me hear. So basically, what we're gonna be doing today is a kind of shorthand of our Intro to Kubernetes workshop with a part of our Lab 2 environment. So what we've done is we've come up, so we built a hands-on training platform for Kubernetes, which we'll be using in the second part of the today's webinar. What we've done is build a self-paced learning platform where you can learn on your own, and here the content is developed by Nigel Poulton, the author of the Kubernetes book. But we've also created a series of this, we call it DevOps boot camps, where we usually work with companies to transform whole teams onto Kubernetes. So today we'll be going a bit through Intro to Kubernetes section, and then we'll be doing a hands-on part where we actually will be doing certain things on Kubernetes to get your hands dirty and to be able to visualize how things fit together. So yeah, this is our full-time kind of bootcamp program that we do. We start with the Intro to Kubernetes, where we build a real e-commerce system, and then there are we focus on each other day on a specific topic of Kubernetes to build like real knowledge, to build production systems, ending with building a complete software delivery pipeline. So obviously we won't have time to cover all of that today, but I hope you enjoy it. So as I said, we're a hands-on Kubernetes learning platform. I think what makes us a bit different is that everything was built for Kubernetes, and I think this will make sense in a bit. What I think makes us different from other kind of platforms out there is, when you're trying to teach 50 different technologies, then you end up with the lowest common denominator, which is just basically a terminal connected to a remote server, which is not very efficient. So as you had mentioned, it started out with the frustration of the current state of learning and proving that you actually know these things. So this is a good kind of showcase of what's out there currently. So step 1, build a stateless hello world app. Step 2, build the rest of the damn cluster. So we're trying to fix this situation. This is what MSB is all about. So we'll be starting with the intro to the Kubernetes architecture, going through a few Kubernetes objects, then going through a kind of mental exercise where we tie it all together, and then comes the fun part of working on a real hands-on lab. If you've already been working with Kubernetes, it could be a bit maybe basic, the whole introduction, but I think it's still good. What we found with a lot of people that have been working with Kubernetes, that they really didn't understand what's happening underneath, and this is probably a good exercise for you to go through. So with that out of the way, I'm just checking the Q&A panel and chat. If everything's okay, we'll be starting. Okay. So how we like to explain Kubernetes is basically a bit differently than maybe what's usually done. A big problem with Kubernetes is actually the amount of jargon that you get thrown into. Basically, as soon as you go inside just a 101 level documentation, immediately you get thrown into stateful sets, API servers, controller managers, things like that. So let's try to kind of avoid it and just think conceptually about how to build a proper system. So basically, let's start with the basic tasks and kind of evolve our system through that. And spoiler alert, yeah, we're going to end up on Kubernetes. But I hope that things will be clearer about the architecture of Kubernetes itself after this. So we're starting with a very basic situation where we have 3 nodes, 3 machines basically running. Each one of them has a Docker install on them. And what we want is a simple concept of let's run our software on Kubernetes. No, let's just deploy our software somehow on the machines. So the simplest way to do it would be just to take, Docker CLI, connect to the Docker daemons, issue Docker run instructions, and okay, here we have our 3 containers running. So technically, we fulfilled our purpose. The system is running, but this is nowhere near a production system, right? So the limitations, some of the things that are wrong with this process is obviously it's a very manual process. There's no healing. If a node goes down, stuff is not going to end up well for you. The IPs are hard-coded. It's just not a good situation. Let's evolve the system a bit. So basically, what we've added from the previous situation where we just had 3 nodes running, let's add a process called exec. Let's just call it like that for now. So what this process will do is just read from a configuration file and it will know then what it's supposed to be running. And let's say it can keep the process alive. So instead of us manually going into each machine and running the, I'm getting some pings from Zoom. So instead of us manually connecting to the Docker daemons, we're going to write a configuration file where we say where stuff is running. We have Nginx, Redis, and Postgres running. And okay, it's a bit more flexible, but still not a good situation. For instance, if a node goes down, suddenly the configuration itself is way too static and there's no way to recover from that. Let's evolve it a bit more. So let's build a bit of a smarter system. So first of what we're going to do is in front of our configuration, let's just call it configuration for now, we'll put a REST server because everything is better with a REST server. So from this moment on, the exec processes are not reading from some kind of static file. There's a central management system that's using the REST protocol to communicate. The second change that we're going to make is we're no longer going to specify, hey, I don't know, Postgres needs to run on node 2. What we will do is only say, I would like these 3 containers to run, and we do not care how to do it. So suddenly, okay, the question from David is, I'm going to answer it live. Why use a REST server? Would SOAP not work as well? It would definitely work as well. I think since we're keeping it conceptual now, definitely SOAP would work, anything would work, but let's just say we chose REST because of simplicity. So as I said, what we've done is now just declared our desired state as these are the 3 things I want running. And let's introduce this process now. So these 2 are fairly straightforward, but what this process will do is just a loop that's basically constantly monitoring the desired state and the current state and trying to make them the same. So basically, the desired state is the static part of our configuration, and then the control loop will constantly compare the current state with the desired state and then issue commands to try to nullify any difference between them. So in this situation, what would happen is the control loop would, just a second. The control loop would see that the desired state and the current state do not match, and suddenly it would issue the instructions, hey, node 1 needs to run this, node 2 needs to run this, and node 3 needs to run something else. So now we have a bit more flexible system. So as soon as all these, the combination of the node and the work unit on this node is known, the processes on the machines can read from the REST server, and suddenly the whole state is known. Let's do one more change to this, simply because we're good engineers. Instead of the control loop both managing the whole comparing between the desired and the current state and assigning to nodes, we will extract a small part of this control loop into a separate process, simply because of some separation of concerns. So we're going to call this process assigner, which basically means if it sees an order, a work unit to be run, and I'm using very abstract terms right now, like a work unit and piece of software and things like that, simply to avoid using some Kubernetes terms, but it will stop sounding so silly very soon. So basically what we now have is a control loop that's constantly monitoring the desired and the current state, and we have a process called the assigner that's going to see if there are some units of work that are not being assigned to a node and assign it to a node. So let's go through an exercise of what happens now. The desired state and the current state are in a mismatch. The control loop is constantly checking these two things, says, okay, this is not good. Issues these three things to be run. They are not assigned currently. At that moment, the assigner realizes there are unassigned work units, assigns them to nodes, and suddenly the exec processes have complete information what they should be running. Daniel asks, can you refer to your current state as a good example of a microservices approach? I think the comparison can work, but not really kind of one-to-one. Yes, but in a proper microservices approach, there would not be like the central state. So the assigner and the control loop are good examples maybe of a control of microservices, but in a full microservice approach, the REST server would be a kind of distributed transaction across these microservices. So what we are using is Kubernetes to run these microservices, and I think through a few exercises later, it will become obvious what I mean by that. So I think this now is a bit more flexible system. I hope everybody was able to follow. And let's just see what happens in a failure scenario. So imagine, as soon as a container goes down, or basically this work unit, it's down, the exec process immediately reports it as the current state is, this is the current state, I'm no longer running it. As soon as that happens, the control loop notices the difference between the desired and the current state, immediately issues this work order. As soon as that happens, the assigner notices there's a new unassigned work unit, assigns it to a node, and okay, the system has healed. Let's see what happens if a node goes down. If a whole node goes down, again, the current state and the desired state are different. The control loop reacts to the change immediately, issues a work order, the assigner realizes something's unassigned, assigns it to one of the available nodes because node 3 is not available anymore, and the system has healed. So we haven't been talking a lot about networking, and it's a bit out of the scope of this explanation, but I hope you now realize that this is a kind of flexible system that's going to respond to changes, and the critical part will be going into the concrete processes soon. But the critical part to notice are these arrows, and which means that at no point did the control loop ping the assigner and say, hey, there's something new to happen. At no point did the assigner notify the exec processes. All of them are just doing one job and doing it well, and basically operating on changes to the central state. They are looking at the central state. As soon as something happens, they respond to it, but all the communication just goes through kind of REST operations on the central REST server. So what we described here in a kind of abstract way, it says spoiler alert, This is basically what Kubernetes is from an architecture perspective. So what Kubernetes is a combination of one or more master nodes and one or more worker nodes. So what a master node contains is, so Sid asks, REST server issues commands to exec. No, all the exec processes, if we go back, all they do is look at the REST server and see, is there something that's assigned to my node that I should be running? So it's a kind of pull mechanism. Everything is responding to changes on the REST, on the central state. And we'll cover the exec process very soon. So this is the master node. Basically, the purpose of the master node is to contain these the central configuration and these sets of processes that are working towards maintaining the desired state. And that's the key part of Kubernetes, where you are just declaring, it's called declaring your intent. You are saying, I would like Postgres to be running. You do not specify which machine, you do not specify details, what to do in which point. You just say, I would like this image to be running. So when we're talking about Kubernetes, literally what a master server is a combination of these four processes. The Kube API server is the central REST server that we've been talking about. On the one hand, what's its purpose is to serve this configuration and allow manipulations over this configuration all through the REST interface. In case of Kubernetes, the configuration is stored in an etcd cluster, which is a key value store. The API server is, on the one hand, a kind of dumb REST server that facilitates communication, but on the other hand, it is critical to everything that's happening in Kubernetes because everything is just looking at the central state and responding to it. So it does also a few other things like ensure validation of your inputs and outputs. It does authentication and things like that. But in the end, its main purpose is to be a REST server to the central state of the cluster, which is the etcd cluster. The Kube scheduler is this thing that we've extracted from, if you remember, the controller manager before. What its purpose, and it only basically does one thing, which is as soon as there is a work unit created that's not been assigned to a node, it assigns it to an available node. The reason it's being extracted is kind of separation of concerns issue. Also, it's swappable in and out. If you want, you can build your own scheduler. But the reason why I recommend that you stick with the default scheduler is because it's actually very powerful. So you can say, hey, just run Postgres and it will run it somewhere. But using certain annotations on this configuration of your Postgres cluster, you can tell it, you can build this kind of hierarchical topologies on the Kubernetes cluster where to distribute these processes on the nodes themselves. And concretely what that would mean is, let's say you want several Postgres instances running, and you should not have them running on the same machine, on the same hardware machine, because as soon as that machine goes down, you lose several database instances, which would be a very bad situation. So what you can tell the scheduler, run this Postgres instance, but try not to put them on the same machine. Or you can say these two things will communicate often together, so try to put them on the same machine. It can do also advanced things. Let's say if you're running some kind of TensorFlow or something, you can say my machine requires a graphics card to be like available. So what it does, from what its only job is, if you are, if there's a work unit that's not been assigned to a node, it will assign it to a node based on certain constraints that you can set. The Kube, David says, what would be like running multiple Azure, AWS, Google Cloud instances? So I don't know specifically what you mean. It's a bit of a broad question. The idea is basically, if you're using a managed Kubernetes cluster from Azure, AWS, or Google Cloud, this whole part, the master nodes, are kind of abstracted away from you. So so it's still Kubernetes, but what it gives you is control over the worker nodes, which provide a resource pool for things to run on. But the master nodes are being maintained and updated by Google Cloud. If you would like to have several Kubernetes clusters on different cloud providers, that's definitely doable, but that's called Kubernetes Federation, and that's a fairly advanced topic of how to actually do it. And I'll give you my contact later. Feel free to ping me for whatever you need. So the Kube Controller Manager is it's basically a process that contains the code that actually does a lot of the magic of Kubernetes. When we say it embeds the control loops, we literally mean conceptually control loops how we would think of them in robotics, because a lot of how robotics works is just having a desired state and then responding to try to get the current state into a desired state. So in Kubernetes, there are a lot of these controllers are being shipped, which are basically patterns how to deploy software to Kubernetes. A very basic one, and if you dealt with Kubernetes, you probably used something called a deployment controller. And what it does is, on its most basic level, is say, I want 5 Nginx instances running. And as soon as, let's say, 2 go down, it will spin up 2 new ones. So basically, its purpose is to maintain a certain number of replicas of something running. All these controllers are available to you by simply declaring them, and we'll see later how. But the Kube Controller Manager is the actual process that literally compiles the code for all these kind of for loops that are constantly checking the central state. This is where a lot of the magic of Kubernetes comes from. So basically, if you're building a Kubernetes cluster, these are the 4 processes you need to deploy. Compile them, deploy them, get them talking through together, and you have a Kubernetes master node running. It's not that complicated, at least conceptually. On the second hand, we have the worker nodes. So the worker nodes are what provide you the actual pools of resources for you to run your software on. You'll see as you're going through kind of Kubernetes journey, if you come from like the old world where you have to think of VMs, suddenly you will start just forgetting about specific machines, and what you will be thinking of terms in controllers and these Kubernetes abstractions that provide you, and what the machines become after that are just these resource pools of CPU and memory to deploy stuff on, and Kubernetes takes care of other things. So the 3 processes that are on worker nodes are a CRI runtime, which means an implementation of container runtime interface, which is basically Docker, Kata containers, Containerd, whatever container system you want to run. They implement this CRI runtime, and this allows Kubernetes to run actual containers. So Kubernetes itself doesn't deal with like pulling the images from Docker Hub, things like that. It's done by something that implements this runtime. The key part, I keep saying key part, all of them are key, but the kubelet process, that's the actual name of the exec process we've been talking about before. It has basically one purpose, and it is receive a list of, let's say, work units or containers that are supposed to be running on that machine, and if something goes wrong, report back. And this is the only thing it does. Question is, when should we use AWS ECS instead of Kubernetes? Maybe for some very simple workloads. ECS is kind of older than Kubernetes. We're going a bit off topic now, but Kubernetes is this kind of great, equalizer. So by definition, a standard Kubernetes implementation has a standard interface, and if you implement your app correctly, you can move between cloud providers very easily. And the problem with cloud providers is that they do not like that. So basically, it will be a race to the bottom on price. So they will always try to get you to use their custom solutions simply because of a bit of customer lock-in. If you're running on ECS, you can't say, hey, Google provides me a cheaper price, so I'm going to move there. You're locked into their API, to their system. So for some simple workloads, maybe ECS, but for me personally now, I don't know, I would run my blog on Kubernetes because it's that simple. I hope that answers it. So getting back, what a kubelet does is literally receive a list of things to run, and this is its main purpose. And the third part is the kube proxy, which is a process that basically ensures that a lot of networking, this Kubernetes not only provides you these workload abstractions, it provides you also networking abstractions, which define how things communicate to each other. And basically, a kube proxy is there to ensure that these networking rules are properly set up on each machine. You very rarely, unless you're like a DevOps person maintaining a cluster, interact with it. It's just there in the background. Okay. So this is the basic architecture of the Kubernetes cluster. I'm checking the Q&A if there's any questions quickly. Okay. If there are no questions, we'll be talking about.
A very quick question, Mislav. Do you see anyone else requesting access to the webinar? Because we have a very round number of 100. It's kind of disturbing.
101. So I think it's all good.
All right, cool.
So we're now getting to the part where I can finally stop talking about these abstract terms like work units and pieces of software, and we'll be talking about actual Kubernetes objects. This is an example of a Kubernetes object. I took a bit of a more complicated example to just be able to show it as the structure of it. Don't worry about details right now, but if you kind of read through it, I think you'll see that it kind of makes sense. So the title of this is Kubernetes YAML files, because this is what we usually do, how we interact with Kubernetes. We write these YAML files, or you can write JSON, but I think YAML is much more readable. YAML is this file format with these kind of sets of indentations and things like that. But the important thing to note is that once you build somebody said, can you please try not to speak half of the text into the off? I don't know what does it mean, into the off. What this means is the structure of this file is basically the same structure as it would be on the central Kubernetes repository. So there are 4 key fields on each Kubernetes object, which is represented here in a YAML file. And when you interact with Kubernetes, what you actually do is use this file and post it to the API server. Or if you're trying to get information, you will get a YAML file structure back in exactly this format. So the key 4 fields are API version, kind, metadata, and spec. Almost all objects have this format. So the API version is basically a way to group sets of objects inside of Kubernetes. So in this case, I'm just skipping ahead, we're using a deployment. So it's in apps v1. You can think of it as a namespace. The purpose of this is to allow the API to evolve without implementing breaking changes. So a deployment is like maybe 2 years old until it's very stable in its API. But before that, it went through something like v1, beta 1 / apps, something like that. And this just is kind of these groupings of objects that we target. How we specify the specific object that we are using is through the kind field. So in this case, we are specifying a deployment file, a deployment object in the apps v1 namespace. We don't need to go too much for now. We'll get there later what exactly a deployment does. But basically, whatever you define inside of Kubernetes, everything is an object always, and the kind field specifies what is the type of the actual object. Next, we have the metadata field. It's again, all of these objects have the same schema, these three types. So the main purpose of the metadata is to hold the name, which is a mandatory field. So every object inside of Kubernetes has to have basically a unique name. So if we think of this kind of evolution with the API version, we're defining just a group, an abstract group of objects. With the kind field, we are narrowing it down to a specific type of an object. And once we give it a name, that refers to a specific object inside of Kubernetes. So the name field is mandatory. The labels field is just a bunch of key value pairs of different labels that you can apply to your objects. On their own, they do not have like a semantic value, but you will see later that they are a very powerful mechanism how to connect different types of objects together. In this case, it's called class deployments. It could be a bit confusing, but it doesn't need to be class deployments. It can be literally, I don't know, tier, front-end, environment, production, role, database, whatever you want to put here. And then we get to the spec field. So the fourth of the four mandatory fields. While the first three always have the same schema and are basically looking the same, the spec field is unique to each type of an object. In this case, it's a spec field of a deployment object, right? So if we go through it quickly, like it looks a bit complicated, but let's just kind of go through it quickly and we can see a few things that stand out. So we can see the replicas field of 2, which we can kind of already assume what it means, basically maintain 2 replicas. And this is again a bit kind of tricky, but we can recognize image. So this is a list of containers. So Nigel Polton MSB hello, open port 8080. So basically what we're defining here is a deployment controller that has a purpose to maintain 2 replicas of this container running. And I think like once you get a hang of it, it will become easier, but you know, there's a structure to it. You can see it makes sense. So this has been kind of an abstract introduction into Kubernetes YAML files. Now we'll be talking about specific Kubernetes objects. Okay, so finally we can talk about pods. So every time I've said a work unit or piece of software or something like that, I meant a pod. So what it means is even though we say Kubernetes is container orchestration platform, you do not deal with containers by themselves. You deal with them indirectly through an abstraction called a pod. And the reason it's been introduced is to allow you to group several containers into a working unit that's always deployed together. So basically what a pod is a group of 1 or more containers that share the same storage and a network and a specification how to run these things. So you can think of them as a few containers that are always deployed together if you are running a multi-container pod, but it is a unit of deployment that basically doesn't work if you separate it out. So as I hinted before, there are 2 types of pods, a single container and a multi-container pod. Most of the time you'll be just running single container pods, just a thin wrapper around your Docker container or whatever you're using. But it also allows you to group multiple containers together. We'll go through an example very soon what I mean by that, but so they are different containers that always work together to maintain a purpose. The question is, can we consider pod as Docker machine in the first image which you have shown? If we go back here, the blue things, these are the actual pods. So what gets deployed, this is a pod, okay? So one key point that I would like to stress, even though you can run like, let's say you are running a Redis instance, even though you can run a pod with 5 Redis instances out there, imagine you want 5 Redis instances running for some reason, or let's say Nginx for scalability purposes. You would not be running one pod with 5 Redis or Nginx instances. What you would be running is 5 pods with a single Nginx or Redis instance. So how you scale up is through increasing the number of pods, not individual containers inside of pods. So a standard example of what we use for a multi-container pod is, imagine we have this situation. So imagine we have a kind of a dumb web server, so just a default Nginx that serves stuff off of its static folder. And on the other, this is the second container. Imagine this would be like a simple cron job or something. Imagine there's like a new content being published somewhere outside of your platform, and you're pulling the content in. So this is a nice way to do some kind of separation of concern. So one container just serves your traffic, and the other container allows you to fetch new content, but they are sharing a volume and they are able to communicate together. So basically what a file puller would do is route to a volume that's actually mounted inside of the shared folder of the web server, and basically they are doing useful work together simply because they are very easily communicating through a shared volume. If we were to scale this situation up, if we run 2 pods of this specification, you can see that everything is doubled basically. So inside of a pod, specific containers are able to communicate very easily, but between them you have to do extra work. So each pod is basically an isolated unit of execution. The thing about Kubernetes is that everything you run, almost all the mechanisms inside of Kubernetes are revolving around pods. But it's also not very often that we are deploying them standalone. We'll see very soon why is that. But basically pod is something that is crucial to Kubernetes. It is what's actually running your Redis instances, Nginx's, custom payment services, things like that. Rahul asks, so we can have multiple pods in a single instance machine? Yes, definitely. So what you can do when you define a pod, you say, I want 2 CPUs and 2 gigs of RAM. And this is how you think in terms of Kubernetes. So you do not think of machines anymore. You just think in terms of pods. You just say, these are my requirements. The machines themselves are there to just provide basically this pool of resources that you require. Okay, let's look at a pod object now, actually. So I think things kind of start making sense right now. So this is an actual pod object that you could write out, push to Kubernetes, and it would be running inside of your cluster. So let's just go quickly through this, how an object looks like. So we have API version kind, metadata, and spec, always these 4 fields. API version v1, which is where the pod object lives, the concept of a pod. So basically we're defining kind pod here, and the third thing we said it was necessary was the name. So we're going to call it Nginx. Basically we can call it whatever we want. It doesn't have to be that, but it's good to be descriptive. And then we have a look at the spec field, and you can see it's much basically different than the deployment one. This is basically one of the smallest instances, smallest YAML files that you can write that are functional inside of Kubernetes, but you can see it makes sense actually. So I don't know, maybe some of you are unfamiliar with YAML, but this basically means that it's a list. So just conceptually, if you quickly go through it, it's just a pod that has a list of containers in it. It has one item inside of the list of containers. We're going to name it Nginx. We're going to specify the image as Nginx and tell it to open port container port 80. And if you publish this to Kubernetes, if you tell it, as we said, declare your intent by pushing this object, you would have a pod that's running an Nginx container inside of it, and port 80 ready to accept traffic. There's a question about the image. Can we also use an AMI image as well? I don't know. I don't think so. I don't think there's a CRI interface for that. AMI images are basically virtual machine blueprints. There is an interesting project, and we used it before called Vertlet, I think, which is a VM virtual machine implementation of the pod kind of runtime interface. And this allows you to run virtual machines inside of Kubernetes as pods. It's a very interesting thing. Another question. So basically, AMI images, no, not without trying hard, because they're not really a container image. The question is, what is the difference between kind pod and kind deployment? So the kind deployment I just showed as an example of, if you specify kind deployment, we'll get to what a deployment is very soon. It just says I'm declaring a deployment object. In this case, we are saying I'm declaring a pod object. We'll go through very soon how these things mix together, but each one of these is a different kind of abstraction inside of Kubernetes useful for doing something. Right now, we're just explaining the pod, and we'll go to deployment very soon. But yeah, the kind is what specifies the type of an object we're declaring. In this case, it is this simple wrapper around one or more containers. Let's have a bit more complicated example. Again, API version kind metadata spec. We're just declaring a pod. We're going to name it 2 containers. This time it's a bit more complicated. You can see in the containers list inside of the specification, there's now 2 items. Still very similar. We're declaring one image called Nginx, one image called Debian, which is a standard Linux distribution. What the Debian image, we are going to specify a command to be run. It's going to do hello from the Debian container. The different thing that we did from before is on the pod level, we declared a volume and we named it shared data. So if somebody, like I would like you to, I'm going to explain a bit more, but maybe try to understand what is the purpose of this container, of this pod. What would we do? So we are using this volume, and you can see we're defining on each container level something called a volume mount. And the name is the same as the volume that we declared, which is important, which means mount this volume, and they're mounted inside different paths in the 2 containers. So if you can see that the same volume has been mounted under pod data here, and it's actually echoing into there. And inside this container, we are mounting it under user share Nginx HTML, which is a folder from which Nginx will, by default, serve its content. So it would be great if maybe somebody tried to figure out what would happen. So this is writing into pod data index HTML. This is writing into the static folder of Nginx, but they are both mounting the same volume. So what would be the output if we made a request to this Nginx process? So if somebody can answer in the chat or Q&A, that would be cool. Yeah, a few of you got the answer correctly. If you're using chat, then you have like a flag. Are you just responding to all panelists and all attendees? So basically what will happen is, some of you got it right, the Debian container will write into the index.html, which will then immediately be visible in this folder because the same volume is mounted. And if we make a curl request or any kind of request to this folder, we'll get back hello from the Debian container. And now you can see how they can basically very easily communicate by just using a few configurations. Mount this volume in these mount paths, and it just works by magic. Okay, thank you for participating. I hope it's fun for you. So an important thing to note about pods is that even though everything revolves around pods, we rarely create these individual pods directly, because by themselves they don't do anything smart. They don't self-heal. They don't they are best when they are managed by one of these controllers that we've been talking about before, and we'll go into deeper one before. The important kind of mindset is, a nice way is to say pods are ephemeral, but there's like a saying, pods are cattle. So what this means is that pods can be started and restarted and moved around, and this is just the reality of a kind of cloud native development workflow. So even though they are critical to everything that we run on cluster, it is what actually defines what we are running on our cluster. We are rarely dealing with them directly, and they are going to be managed by a controller. And we will be covering one controller very soon. It's just important to note, pods are cattle. This is a kind of good way to remember. Let's go into a second Kubernetes abstraction. Just as a pod is a basic abstraction of a workload that needs to be run, a concept of a service is a basic abstraction of networking inside of Kubernetes. What this means, I think it will be very clear on example how this works exactly. But as I said, even though pods have their own IPs and ways to address them, they are going to be moved around, and there is no kind of central way to keep track of where they are if you need to send traffic to them, which you usually do. So to get around this, we're introducing something called a service. So when you declare a service, it's a networking abstraction which will route all the traffic that it receives to a certain set of pods. And we'll see how we define these pods soon. Okay, T has a question. I'll answer it very soon. The services themselves are basically a networking endpoint inside of your cluster that you can be sure will not be moved around. So all the traffic that is routed to it will be routed to one of the responsible pods that will reply to it, but kind of by magic. You do not think about specific pods. You are just talking to this service. As I said, the purpose for a service is, imagine you have Nginx servers, and you have, let's say, 3 of them, and suddenly there's like Black Friday or something is happening, and you need to scale it up to 50. Okay, there are a few more questions. The idea is that if there were no services, then you would have to keep track of all these 50 new pods that are the Nginx cluster, the Nginx servers that are routing traffic, and we do not want to do that. So what we are declaring is this networking abstraction, which will create an IP and a port, and all the traffic going to it will be served to the pods in the backend. So whether there's 3 or 50 or 2,000, we do not care. The service itself takes care of that. Okay, let me answer a few questions right now. One question is how best to do fault tolerant and replicated storage in Kubernetes if my pods are moved from one node to another. Yeah, storage is a very tricky part. In every deployment, and also Kubernetes is the same. We have a whole kind of workshop around it, and I think there's content on MSB itself about it. But what's important to note is that everything inside of Kubernetes is an object, including storage. So how you actually do it is you use a special type of controller called a stateful set, and the volume that actually contains the data is abstracted away as an object. So what you do is, if a pod goes down and you want and goes up again, maybe somewhere else, it's connected to this storage object, to this storage provider again. So on MSB, we have actually an NFS storage provider. So you can manually declare, here's 10 volumes, NFS volumes, and then you can have pods attached to them. And if one pod goes down, the volume itself will survive. So this is the basic principle behind it, but it's hard to go deeper right now. Another question is, do we use a node selector, or is this being deprecated? If you're talking about, I need more clarity right now. Are you talking context of services, or in context of I'm blanking out, the assigner, the scheduler? I'm just gonna get back until I get a bit more clarity about the question. So, as I said, pods are going to, they're not obviously not changing constantly. They're not like Kubernetes won't kill your processes randomly because it feels like that. But the system has to be architected in a way where that is possible. That is the principle behind it. So what a service is this entry point, an IP address that will magically route to load balance your traffic across the pods that are responsible for managing this traffic. So I'm going to go back to this, but let's quickly have a look at our service object. As you can, I hope this is becoming familiar. API version kind metadata spec, it should be a bit familiar. So we're declaring a kind service in this part. So this networking abstraction, it's in the API version v1. The name is mandatory. We're going to call it my Nginx in this case. And this is a very simple kind of specification on route traffic on port 80. And then the selector is the key part. And I'm going to now just show this side by side. If you remember, this is the pod specification. Here, this is what's actually going to be running the container, the Nginx container. This has to be actually indented. So there's a bit of an error here. And if you remember when I said the labels, you can name them anything you want, but they are important how to kind of group various objects together. Here we can see that the selector of a service and the label of the pod are the same. They're run my Nginx. And this is how you basically determine to which pods this networking endpoint should route traffic to. So you can have several of these here, and they're all kind of ended. So you can have something like tier front-end environment production. But the idea is, once you declare this service, an IP address will be created, and all the traffic going to, in this case, the port 80 of this IP address will be routed to one or more. It will be routed to one or several pods that are in charge of answering this traffic. So the service will always select a pod via label. Yes, this is the main kind of thing that you should remember from services, and we'll see how it works. We'll be running a hands-on lab later to do it, actually. But yes, labels are a very important mechanism. So as I said, they don't have a semantic meaning. You can name it whatever you want, but they are very important how these parallel processes inside of Nginx recognize and communicate with each other. So what a service does is routes traffic to a subset of your pods based on their labels, which is defined by the selector. Faisal says, I don't think you can see it. Faisal maybe use the all panelists and attendees. So you just mentioned Kubernetes API object. So does it actually work as pods, then deployment service, and then persistent volumes? Okay, Vic. all of these are Kubernetes objects. So a persistent volume is a Kubernetes object. I don't know what does it mean. It works as all these objects that you specified work they have their roles. So the 4 types of services that exist are a cluster IP, node port, load balancer, and external name. The cluster IP one is the default type of a service. What it will do is create this magical IP address available from within the cluster, and all the traffic going to it will be routed to one of the pods that have a correct label. The second type of a service is a node port service. What it will do is it won't only create this magical kind of IP address, it will also open up a port on each node, on each machine of your cluster. So all the traffic going to any machine of your cluster on this port, the traffic will be routed to certain pods. This is a very kind of DevOps-y kind of type of a service. It's more to kind of expose maybe your logging subsystem or something like that. So it's not something that you do in your day-to-day work. The load balancer service, and this is a very cool one. So as I said, if you define a cluster IP service, it will open up an internally available IP address. But if in a correctly configured Kubernetes cluster, when you say, I want a type load balancer service, it will actually give you a publicly addressable IP address using your cloud provider's load balancer. So MSB is running on GKE, and so we'll actually, as soon as you request this one, you will get a real Google IP address that you can use. But why I like this example is basically it shows you this kind of messiness that Kubernetes abstracts away from you. So in a correctly configured cluster, all you say, I want a load balancer service, and you don't care if it's running on GKE, AWS, or wherever, you will get a publicly addressable IP address that will route traffic to your pods. How it happens is a bit complicated, but you do not really care. And this is why I said the cloud providers don't really like Kubernetes, because unless you're doing something, I mean, they have to, invest in it. It's becoming standard now. But unless you're doing something very complicated, you should be able to take the configuration of your application and move it to another cloud provider very easily, because all these kind of edge cases and specific points of each provider's API are just abstracted by a standard abstraction. And the final one is just an external name. It's just an alias to an externally available address, which isn't used very often. Okay, so we covered this. And finally, we can talk about deployments. So it's one of these controllers that we've been talking about, and I think things will kind of make sense after this. The controller, a deployment is one of the controllers offered by Kubernetes. If you go to Kubernetes.io, you see a deployment provides declarative updates for pods and replica sets. And this is one of the maybe problems with Kubernetes. It just throws this jargon out there, but technically it's true, but if you're just new to it, it doesn't help much. So a deployment is a controller, which means you describe a desired state, and then it will do things for you based on what its purpose. In the case of deployment, let's just say for now, its basic purpose is to maintain a set of replicas running. If we say, I want 5 Nginx pods running, it will maintain 5. If 3 go down, 3 new ones will be started immediately. So this is what it does. And this is, if you remember when I said you wouldn't usually deploy pods directly, because you would do them, deploy them through a controller or put them under control of a controller, which will then give you self-healing or whatever this controller provides. So now let's go through a deployment object. It should become a bit more familiar to you now, I hope. So API version, kind, metadata spec, always there. EPC1 deployment, we're going to name it Nginx deployment. In this case, labels don't do much, but you can label anything. And let's just have a look now at the spec field. So spec is the one that's unique to each kind of an object. In this case, this is a specification for the deployment object. This is where all the configurable things for this controller go, or this type of an object. So just quickly, we can see replicas 3, which means maintain 3 replicas running. And then if you could skip to the template field, and it would be great if you had a look at this a bit and told me if it reminds you of something. Osama says how to control number of pods in the deployment. The question is how to control the number of pods in deployment. Basically, you would edit this field. So you can say 3, 5, 50, 3,000, something like that. But maybe if you focus, does this just what's in the template? Does it look familiar? Yes, I'm getting into this. Thank you. Yes, it is actually the pod specification. So it's just missing like API version and kind because it's assumed, but this is a pod specification. So you can see that it's a list of containers running nginx container port 80. So this is what I mean under the control of our deployment. Thank you. So what this does is you can think of it as a factory to maintain 3 replicas of pods that are produced using this template. So this is how it will work. The cool thing about the deployment is that it allows you can plug a few things in it later. We'll talk about it in a bit, but let's just say you can use something like a horizontal pod autoscaler. It's called Kubernetes naming is a bit funny. But what it allows you is another object that will interface with the deployment object. And you can say if the pods, if my pods are getting over, let's say 50% CPU usage, scale up or scale down. So this allows you to kind of create a breathable system that scales up and down, which is, we won't be doing it now, but just so you know what the purpose of a deployment controller is. And now before going to the hands-on part, let's just go through a kind of mental exercise where we're trying to go through all of this together. So, just a sec, please. What we'll be walking through is a similar example as before. We would want to run 3 containers, but this time in a much more kind of Kubernetes context. So let me just quickly explain to you the kind of UX of this schematic. It's maybe not the best, but I hope you'll be able to follow. So when you see, let's not get into exactly what it is, but when you see kind of all these black boxes are kind of controllers. And when you see text in here, that means it's not the internal state of each controller. What I mean by that is this is the data from the central repository that it's interested in. This just kind of makes it easier to see how a controller views the world. So the actors in these exercises are a deployments controller, which is this thing that maintains a certain number of replicas running. A kube scheduler, which is, if you remember, this thing that assigns pods, we can now say pods, to available nodes. And I'm just going to briefly introduce something called an endpoints controller, which is not something you interact directly, but just so you know how it works in the background. If you remember, this is a service, and if we declare a service, it needs to maintain a list of pods that it should route traffic to based on their labels. And what it does for the job of just a sec, who fulfills this task is actually a controller that's created automatically called an endpoints controller. So what an endpoints controller does is maintains a list of running pods that have these labels that are required. So this is its only job, and this is how a service knows where to route traffic. So let's go through a situation where an intent to run a deployments controller that's going to be running 3 Nginxes, and it's going to be exposed through a service, which means traffic should be routed to it. I think it will become a bit clear soon. But in this scenario right now, we have nothing running on our system. The deployments controller knows it has to run 3 Nginxes, and let's see what happens. Just remember, this is all the actual communication is going through the central state. So as soon as the deployments controller got the intent to run 3 Nginxes, it sees, hey, there's nothing running, the desired state and the current state are different. It immediately schedules 3 Nginx containers to be run, or pods. As soon as that happens, the scheduler sees, hey, I have 3 Nginx pods that have to be run. They're not assigned to a node. I will assign them, assigns them to a node 1, 2, 3. As soon as that is done, the kubelets, the exec processes, or kubelets, which is their actual word, have the complete information to run, and they are deployed on their own machine. So at this moment, let's just say at this exact moment, the images got pulled, everything is good, and at this exact moment, the pods went into a running state, and it's been reported to the central repository. So as soon as that happens, 2 things happen. One is the deployments controller, you can see it was scheduled, it now sees, hey, they are running, the deployments controller is happy. But in parallel, the endpoints controller, if you remember, it's the job of the endpoint controller is to maintain a list of running pods with correct labels. In this case, they're set up to target app Nginx. As soon as it goes into a running state, it sees them, and the service knows how to route traffic to them. And what's important to note is that these 2 controllers, and it's a bit complicated maybe visually, but it's important to see that it happened in parallel. So both of them are just looking at the central state, and both of them have noticed this change and did their job. Let's just go through a scenario where a pod is going to go down. We're going to be killing this pod, whether we manually shut it down or something goes wrong or a cosmic ray corrupts the RAM, it doesn't matter, it's going down. So as soon as it goes into a terminating state, now it's going to be reported to the central server. As soon as that happens, we can see that the deployments controller notices, hey, it's terminating, this is not good. And at that exact moment, the endpoint controller also sees, hey, it's no longer fulfilling my criteria of being a running pod. It gets removed, and the traffic is no longer routed to it. And the deployments controller, if you remember, it has to maintain a number of replicas running. As soon as it saw one is terminating, it's not happy anymore. It schedules a new one. The scheduler immediately notices it. It's not assigned, assigns it to a node. The kubelet says, hey, I should be running Nginx 4. I'm not doing that right now. Okay, I'm running. And as soon as it goes into running state, the endpoints controller recognizes it, the deployments controller recognizes it, and the traffic is restored, and everybody's happy. The key part is to notice that at no point did the deployments controller ping the scheduler and say, hi, hey, I have some work to do, or these 2 communicated, nothing communicated with each other. All of them are just looking and reacting to the central state and doing their one job, but doing it well. And through their kind of simple interactions, a kind of higher order functionality emerged, which is a self-healing system that can route traffic to each other. It is very important for me that you at least conceptually understand what happened here. So if there are any questions, now would be a very good time to say, to ask them, or maybe even just say, hey, I got it, this is good, just so I get some feedback. Okay, I'm getting that things are clear. If it's not, please, yeah, don't be worried, just ask and we can go through it. But okay, the final thing is how we interact with Kubernetes. Basically, This got a bit messed up, I'm sorry. We are using a kubectl or kubectl, how you want to pronounce it, command. So a kubectl is a binary that you have on your machine that you can execute. It reads from your kube config locally, so it knows where the API server is. And every time you are basically interacting with a Kubernetes cluster, you're using the kubectl command, just because it has a lot of these authentication automatically and does a lot of nice things for you. But in essence, what it does is just does a series of API requests in your stead to the central server. And how you deal with it is in the standard format. So basically, if we look at kubectl get pods, that means kubectl get all pods, right? If we want to target specific objects, then we're doing kubectl get pod / name. So in this case, get the information about pod, nginx, replication controller, Postgres, service, frontend. Doesn't matter the details, like this is just so you know how to address objects inside of Kubernetes. So this doesn't have to be get, this can be delete. And in that case, it would be, hey, delete these 3 objects. So if you don't specify a name, that means all objects of this type. So kubectl get services or SVC would get all services. But if you specify a name, that means a specific object. The question is, sorry, what is Postgres in here? Postgres is something we call a replication controller. It doesn't matter. Let's say we declared an object called a replication controller, which we don't cover now, just one of the controllers, but it can be a deployment named Postgres. It's just to talk about the format of the kubectl command. And the final thing before we go into the hands-on part is the apply command. So every time you have something, a YAML file that you would like to publish to a Kubernetes cluster, the easiest way to do it is just to use the apply command. Kubectl apply -f, -f means file name. So what this will do is take whatever is this in the file, if it's a pod service, whatever it is, it's just gonna, let's say, post it to the API server and say, hey, run this. So we'll be using the apply command a lot to actually run stuff on Kubernetes. So this concludes the theoretical part. We're finally going into the fun part, the hands-on lab. I'm going to be spinning up, it seems, 85 clusters or so for you in the next 2 minutes. But let's take, let's say, a 10-minute break. And I'll be answering questions here. If 10-minute break is too much or not enough, please let me know, but that's our standard kind of break that we do. If that's okay, I'll be here on the chat. I'll be taking like a 2-minute break and then I'm back on the chat to answer any questions. Otherwise, see you in 10 minutes. Hello, everyone. We'll be resuming now in a few minutes. I'm just spinning up your clusters. There's been a few questions. Let me kind of go through them. Oh, you guys are answering by themselves. Awesome. So the question is, how would they prevent RabbitMQ and Postgres and MongoDB and Redis all allocated to the same node? What you can do is specify inside of a pod specification an instruction to the scheduler not to deploy them together. We can have a look later, but you can go to, just a sec, I'll send the link. So there are two nice blog posts on Kubernetes IO where you can see required during scheduling, ignore during execution, which means if something is running already, ignore it, but you can say, I would really like not these three to be on the same pod together. So it's a bit of an advanced, not that complicated, a bit of an advanced topic. We can't go too much into this, but Martin answered it, yes, very well. So you can do it with certain labels and say everything containing these labels should not be run together. So I need to spin up 8 clusters, let's say, just a sec. So, okay, I'm happy. I'm gonna am I sharing my screen right now? I guess so. And this looks a bit messed up. So what we will be going to, everybody, is workshop.msb.com. So when you go there, you'll be welcomed by something like this. So 2 things, please use Chrome. It works on other browsers, but best with Chrome. And the second thing, you need to create an account. So if you have a Google login, that's the simplest way. Just click login with Google and an account will be created. Otherwise, you can click here on the sign up here page to create just a quick username password and you will be inside of MSB. So you will be seeing this kind of interface, and let me just go quickly to the point here. So you will be welcomed by something like this. This is our kind of workshop module where we have a few scenarios that we've opened up. I'm going to wait like 2 minutes and I'll be checking the chat to see if anybody has any issues. But in like a minute or 2, I'm going to assume that everybody's here with an account and sees this exact screen. Workshop.msb.com. So yeah, 2 things. Chrome, you have to create an account. Best way is just to log in with Google. Otherwise, you can see here, log in here or sign up here, just create a quick account. And if possible, use a big screen. It's best on a big screen because there will be a lot of things going on. Okay, from this point onwards, I'm assuming that we are here. What we will be doing, and I think all of them are now open. So there's always somebody who's not listening to me right now, but we can fix it easily. So what's very important is that you click here on 0 downtime deployments. So this is the topic we'll be covering. And inside of 0 downtime deployments, we'll be clicking, you will see a green, actually, start button here. For me, it's restart because obviously I did it a few times. But we'll be working 0 downtime deployments 0 downtime deployments intro, and then the green button here. And I'm going to click it now and give it a few seconds. And if there's no feedback, I'm assuming that everybody's here in a few seconds. Can somebody say, is this good? Are we all here? Okay, awesome. So right now you're connected to a real cluster. We are now logged into MSB. Just a quick kind of introduction of how things work from a UX perspective. Don't click next step. Okay, let's see. So what we are now connected is the MSB learning environment. You all have a real cluster connected. Let's just go through a UX very quickly. So we'll be going forward by clicking on this green button to kind of go forward. So whether it says start tasks or proceed or whatever, whenever I say let's go further, I mean this button. Second important thing is if you're on a big screen, you can resize this left pane, left or right. So you can adjust how you want it to be. Basically, on the right here, we have a live representation of your cluster. It will become clear soon what I mean by that. So leave a bit of space for this. Let's click Start Tasks to go to the next slide. This is our basically work mode. And here you are connected to a real cluster. So just one more thing I want to show you, which is this button here. So not the right one, the left one here. So if you're maybe on a small screen and it gets a bit cluttered, if you click on this one, inside of a new tab, a full ID will be opened up. So it's connected to the same cluster, the same files, everything is the same, but it gets useful in a bit more complicated, these hands-on labs that we're doing. But if you want, you can use the ID environment, or you can simply work here. It's all the same. So let's just quickly run. So now we're in task mode and says, first, let's practice. Let's do this. Let's run this command. And so what we'll be doing is we'll be running the apply command that I mentioned before, how you instruct Kubernetes to post something that's locally in your file system to the cluster. So what we'll be doing is, if we open up the pod.yaml file, which we'll be applying right now, it's just a definition of a simple pod. It's going to be running a BusyBox image, which is a very kind of, let's say, lightweight Linux distro. And it will be just echoing hello Kubernetes and sleeping for a bit. So a very simple example, but let's run this command. So kubectl apply f pod.yaml. Okay, now we see something happening in the right part, which is the live representation of your cluster. So this is a pod that just got deployed to your cluster. I don't know if I can zoom a bit. So these green kind of buttons represent actual objects that have been emitted by Kubernetes for this specific object. So you can see that this is the scheduler assigning it to a worker node, the image has been pulled, and the container is running. One other thing inside of MSB, if you click on the name of any objects, in this case here, my app, because that's the name of the pod, a detailed view will be open with a lot more kind of information about this object. So if you hover over any of these kind of keys, you can see the actual purpose of it and what does it do. So it's a very useful kind of debugging environment and just to learn to see how things react and how things are working. Okay, with that in mind, let's go next and run a next command, kubectl. You can see it's spelled up here, logs, my app. And we can see hello Kubernetes. So this is the actual echo that is being logged here. My app is the name of the pod that we have given to the pod. And the logs command is this kind of nice shorthand that kubectl gives you to quickly see what was outputted on the std out of a container. So with this example, with this, let's just delete it now. So another kubectl delete pod myapp, which means type current pod, the actual name of the pod myapp. To delete it, we can see an event stopping container myapp container, and this has been just basically a trivial example to introduce MSB in Kubernetes a bit. For some of you, this may have been the first interaction with Kubernetes. I hope you've been following what's happening and will be doing a bit more interesting things right now. What we'll be doing now is going through a small exercise, which is a part of our zero downtime deployment. It's basically a full day event that we are doing with companies to get their whole teams on Kubernetes. I like this example here because it's not just a trivial hello world example. It will give us a kind of goal to achieve, and I think that's a much better way to learn things instead of just running basic commands. So first of all, what we need to talk about is deployments in a bit more detail. So this is the type of a controller type object, the one that kind of maintains a desired state. If you remember, I said that its purpose is to maintain a certain number of replicas running on its most basic state, and its most basic kind of purpose. There's a few more things that it does. So the three main things that a deployments controller does for you is self-healing, which means maintaining a certain number of replicas running. If you tell it to maintain 10 replicas, 3 goes down, 3 new ones are scheduled immediately. Scalability, which means you can scale it up and down, either manually or scale the number of replicas live, either manually or through something like I mentioned before, the horizontal pod autoscaler. And this will be doing a lot is something called rolling updates. So what rolling update mean is a gradual way to update your containers, but not by updating your running containers, but by shutting down old ones and creating new ones. So imagine you're working on your payment service version 1.7, you've been working, you pushed version 1.8, you want to deploy it, and through a deployment, what you can do is gradually shut down the old ones and increase the new ones. It will become clearer much soon. Okay, we went through how our deployment looks like. We don't have to go through it much now. I'm moving forward a bit until we get here. Let's run kubectl get nodes just to see we're on a real cluster. So you can see that nodes, a node in a cluster is an object like any other. So when you do kubectl get nodes, that means list me all the nodes inside of a cluster. So you can see we're running a master and 2 worker nodes. So you're working on a real Kubernetes cluster. So if we do kubectl cluster info, specifying the task, you can see some basic information about your cluster. It has DNS deployed. So what we've done in MSB is we try to provide as production environment as possible, which means we have load balancer, support services, did magic services. We have persistent volume. So basically, even after that, even after the workshop is done, if you want to learn or play around, you'll see there's a whole self-paced environment, learning environment on MSB, but also just to mess around and see how things work. It's fun. I don't know, did I answer these questions? There's a question by Graphid. I'm sorry, I didn't see these things. I think we'll be actually doing something right now that will show you how traffic is routed. Literally the next exercise we do is going to be about routing traffic. More question is, how do we configure auto scaling with the pods, increase more pods but the traffic is more? So basically you can push, usually you do use something called Kubernetes metrics, which is an internal mechanism. So certain metrics you have out of the box, something like CPU usage. So that's the most basic one. If you say, if all my pods are above 50% CPU, then increase them. but you can use custom metrics to like literally number of requests or things like that. Can we configure Kubernetes to get image from other repository other than Kubernetes? So there is no Kubernetes image repository right now. When we're pulling images, we're pulling from the main Docker Hub repository, but you can definitely specify other repositories. It's standard, you know, container Docker process. With zero downtime, does it become massive pain migrating or handling any data changes? So yes, definitely. So data is always tricky. There are two parts to this question. One is the, let's say, breaking API changes. So this is very tricky to do, but so, you know, Kubernetes does a lot for you, but it's not magic. So, but it provides a lot of mechanisms if you know how to use it well to actually facilitate a lot of what you want to do. But if API changes, of course, it's a pain unless you have proper versioning built in. And especially with data changes, if you're dealing with volumes, that is definitely a pain, but it provides a whole controller just to maintain that. And we have a whole kind of whole day workshop on it. And we can maybe talk later. Let's talk about specific, okay, let's see, Q&A. Okay, that should be. What we'll be doing now is going through two different scenarios. They're very similar, and what we'll be doing, we'll just be using two different sample images. One is one is called a simple server, and one is called a delayed server. So what they will be doing is both contain a very small Go program that's listening on port 8888. And it's just configured to return its host name, which inside of Kubernetes will be the name of the pod itself, which will be useful for debugging things. The difference between the simple and the delayed one is that the delayed one will just wait for 10 seconds until it actually starts routing traffic. And the purpose of this is to simulate a scenario where a process is running, it's just not doing anything useful. And it's a very common kind of pattern. Maybe you're running a large Java process that needs some warm-up time, or it's running schema migrations, things like that. But from Kubernetes perspective, if you think how it sees the system, from its perspective, the process is running, and that's all Kubernetes knows, and it's all good. From a user perspective, from us interacting with the process itself, it's not good because it's literally not doing what it should be for 10 seconds, which is answering network requests. And then we'll see how to solve this problem. So, okay, let's click next. Let's go into work mode, and let's have a look at the application we'll be deploying. So if you remember, we're going to now deploy a deployment. We're going to just name it simple. If we look at the template field, which means we will be deploying an image magic sandbox simple env server, which will be listening on port 8888. We didn't specify the number of replicas, so by default, it will maintain one replica. And if it goes down, it will pull it up. So a very simple example, let's just run the command and see what happens. Okay, we have a similar situation to before, but things are a bit different right now. So before, when we deployed just the pod, you could see just this kind of blue image of a pod itself. But right now you can see that it's wrapped between two different intermediate objects. So whenever I said that deployment maintains a certain number of replica sets, a certain number of pods or replicas, I've been lying a bit, simply to keep things simple. A deployment actually maintains a replica set object, which in turn, as the name says, maintains a set of replicas. And we'll see very soon why that's useful. As usual, like if you hover here over any field, you can see a bit more description about it. If you click on any of them, you will see a lot more information of what the cluster actually gives you. But what we did now is create a deployment that maintains one replica of our image magic sandbox simple image server. So just to show you, you don't have to follow, you don't have to do it, but let me just show you what the deployment does in kind of real terms. I'm just taking this pod and I'm going to delete it. So just pay attention to the screen. So as soon as it went into stopping container mode, you can see a new one got spun up. This one will be gone. If we were when we killed our old pod, it basically stayed dead. But with when it's under the control of a controller, you can see immediately a new one got spun up. So this is the self-healing mechanism that we've been talking about. Okay, so another thing that we have to do is let's deploy this service. So let's run this command now. I'll explain why I'm rushing the command a bit. So kubectl apply f service.yaml, and then I'll explain exactly what it does. So as soon as you run it, you can see it appearing here. So this is the service we just deployed. And if you remember how it works, and this is a standard pattern of how we use deployments and our service together, basically what a deployment does is maintains a certain set of replicas of this pod, and we assign it a label. And then if we use that same label inside of a service, so that means the service will expose all the pods that are part of this deployment. And what that means that now is that we can just scale this deployment up and down, but only contact the service simple, and it will route traffic to the pods themselves. So if we have a look at our pod, we can see from its configuration that it has a label app simple. And if we look at the service definition, we told its selector target everything with the app simple. In concrete terms, what that means is, so this ID itself runs on the cluster itself, inside of the cluster. So this is why this will work right now. But in practical terms, what this means is that every time you want to target one of these pods, you would target the IP of this service. And an even better way to do it is when you create this, it creates basically a DNS record with the name of the service. So let's run now that we've deployed it. We can just do curl simple. So a curl is just creating a HTTP request to this host name, which is the name of the service itself. And if we run this curl simple, we can see the response from the pod itself, which means this pod returns its host name, and basically we are communicating to this pod through this service. So we can just, so if we have like a Redis service, whatever we want, we will just do curl Redis port 6378, and it will be routed to one of the pod, to Redis pods. So is this pattern clear what we just did right now? So this service routes traffic to all the pods with a certain label, in this case only one, but we're just using its name to route traffic there. If somebody doesn't understand, please let me know, but I'm gonna, and a lot of times, like there's a group of people that don't understand, but they're afraid to kind of speak up. If you don't understand, there's probably a lot more people that don't, so please just let me know. Okay, in a concrete terms, what this means is, let's have a look at our pod. So as I said, the pod did get an IP address, and here, if we look at a bit more information about the pod itself, here we can see the actual IP. So instead of going through a service, we could have done curl IP address, and it's listening on port 8888. So we can directly route traffic to it, but we do not want to do it because pods are kind of cattle. What we are actually doing when we run curl simple is using this cluster IP, which gets created with every service. So instead of contacting the pod directly, and if this pod dies, a new one gets created, the IP changes, and suddenly we lose all this information. When we run curl simple, we're actually targeting the the service cluster IP itself. So however pods that are here in this deployment, we're just targeting the simple one, and it will get a response. One thing in MSB, instead of curling all the time, is you can actually click on this port. So you can see in the service definition, we have this port, and if you click this, we will send an actual request through the cluster, and you can see the response. So this will be a very useful debugging tool for us. So instead of curling, we'll be clicking on this port basically and just sending actual requests to the system. Another thing why I wanted to deploy the service quickly is if you paid attention, we're specifying its type as a load balancer service, which is one of these magical services that provides you an externally available IP. And we can actually use it now. So it usually takes a few minutes for this to set up, because we're actually providing like a Google load balancer. So it's not up to us. Sometimes it takes 5 seconds, sometimes it takes 5 minutes, but let's see if it works. So if you run kubectl get services, your simple service, if you, like most of you should have it, should have an external IP available here. So kubectl get services. Otherwise, you can just click on the name of the service here, and you can see status, load balancer, ingress. There's an IP here. So the cool part about this whole thing is we just specified type load balancer, but I'm not gonna go into another tab to this IP. So this is publicly available. You can even go to my IP service, to my IP, and you can see we have an exposed pod serving traffic to the outside world. I think that's very cool. A lot of times when we're working through this exercise, it will be very useful for you to think what would it take to do this without Kubernetes, especially once we get into rolling updates now and things like that. I just think it's very cool. So is this, can I get some kind of feedback? Is this working for you guys? Did you get your IPs? Yeah, T said, I don't have an external IP, it says none and pending. Yeah, some of you might need to check a bit or maybe refresh a few times, because it's about Google and how long it takes to assign it to you. It's not really that important. I just wanted to show how cool Kubernetes and MSB is. But for a lot of people, it seems to be working. I just see Anas had a question. Is there a way to measure downtime between a pod being terminated and newly spun up pod from being 100% running? Yes, there are two mechanisms there. You can specify how much time a pod has to shut down, so it will get a sig kill and it has to, or sig term, and it has to like terminate itself within this kind of time limit. And also you can, and we will be doing that inside of a rolling update, you can specify the rate of new pods being created inside of a deployment. Okay, I hope you think this is cool. I do think it's cool, but okay. So this is just a simple kind of example to show you what Kubernetes does. So let's see how actually services and a deployment work together. So Ben has a problem. I click the icon that looks like a copy function from the top. Ben seems to have some cluster issues. Ben, I don't have much. So Ben has issues with. He went back to the home page and now it won't resume what it's supposed to do. Ben, do you maybe have another Google account that you can use to quickly log in? to get a new cluster because I don't have much time to now. Like it's very weird. That shouldn't happen. What's happening to you? I'm going to continue with this. But if you can try on a different account, that would be amazing. Okay, thank you. Let's run this kubectl scale deploy simple replicas tree. So actually, I'm going to type it out. So kubectl scale is another kind of command. Scale is one of these nice things about kubectl that gives you. So deploy simple, which means a deployment, deploy is a shorthand for deployment with the name of simple replicas tree. Okay. Now a few things have happened. You can now see that there are actually 3 replicas or 3 pods under the control of this deployment. So in practice, what this means with this in combination with the service, if we run now a few curl commands, you will see that different pods are responding. Okay, I'm unlucky, it's all going to the same pod. But basically, what we are now, I'm going to be clicking here. So if you click a few times, you will see different host names, which means different pods responding. So this is the purpose of a service. So there can be 1, 2, or 3,000 pods here behind it with the correct label. We do not care about their individual IPs. All we do is route traffic to the simple one, and it's going to get distributed around these pods. So this is a very common pattern. You deploy pods in a deployment and expose them to a service using a common label, and it's all going great. You do not, like, the system can scale up and down easily. So, okay, let's go forward. So what we'll be doing now is final part of this cycle that we'll be doing once more is something called the rolling update. So let's go back to our deployment simple.yaml. Imagine we're running Magic Sandbox Simple and Server 1.0. Imagine we're deploying version 2.0. So we pushed it to an account, to a repository, and we want to upgrade our system to a new version. So we'll be doing that now. So all we need to do is edit our YAML file. Basically, inside of the image, change the version from 1.0 to 2.0. It will autosave. And then let's reapply this file that we've just edited. So we've been working in deployment simple.yaml. So kubectl apply f. After you change the image to 2.0, deployment simple YAML, and okay, things are now happening on the screen. So a few things have happened here, and I like this example because we just performed a rolling update. So a few things have happened. Ash says, this is so cool. Thank you, Sam. I've been waiting for somebody to say something. This is cool, but you've been kind of quiet. But yeah, thank you. So what happened here is we just performed a rolling update. So the old replica set shut down, a new one got created, and now we have 3 new pods that are running here. So let's just think of, from a functionality, how we would interface with this. This service now targets these 3 new pods. So when we just switched the whole kind of software behind it, but since the labels stay the same, the service continues serving traffic, traffic gets routed, it all works nicely. The second thing that happened is a new replica set got created. So the idea behind these replica sets is that they are kind of history of your deployment. So the idea is, if you can just watch the screen a bit. I will post some string. I don't know what the string means, but if you can look at the screen a bit, imagine we just deployed something went wrong. So we can just do quickly kubectl rollout, undo, deploy simple to kind of roll back our deployment. So let's say something went wrong, we quickly have to fix it. We quickly have to go back to an old version. We can do the same process in reverse. So why we build this kind of interface is so we can explain what's actually happening inside of Kubernetes. If I were to try and talk to you, deployment maintains a replica set, which gets then a new one gets created, things like that. It's a bit complicated, but when you see it here visually, I hope it makes sense. What happened here. So I'm just going to go back to where we were before. But this is the purpose of a replica set. So deployment maintains a replica set, which in turn maintains a set of replicas, simply to have this kind of history of your deployments back. Similar to version control. Yes, definitely. So the cool part is during this transition, like the service, if you remember what a service does, or actually the endpoints controller, it maintains a list of pods that are active and have this label. So as we did this transition, the traffic went through nicely, it's all good. So if this is all clear, we will be going to the more kind of tricky example. So let's get rid of our deployment. And our fancy public IP service. This is just to clear like the screen a bit to have less distractions for what we'll be doing now. So we'll be doing the same thing as before, but if you remember, we'll be doing this with this kind of tricky service where tricky processes where we actually they sleep for 10 seconds, which is simulating some startup time. And we'll see the problem that come here. So let's have maybe just a quick look, standard deployment that we did before. We'll be actually working with the deployment delay.yaml. So I'm going to close the other ones down. In this case, it's very similar to what happened before. It's just that we are not running simple env server, we are running the delayed server right now. So let's apply it. So right now, it looks very similar to before. So to access these pods, we can use their IPs directly. We do not want to do that. We want a service. So we should do what we did before, which is create a service YAML file that ties it all together. I just want to show you that another quick way that you can do with kubectl. You can run kubectl expose deploy delay, and it will do it for you automatically. You shouldn't do this usually because it will not be represented in your YAML files, and if you try to recreate, it will be broken. I just wanted to show you quickly that you can do things manually inside of a cluster. Ash says I'm an excellent teacher, but he has to go. Okay, Ash, thank you. If you want, just so you know, for the end, if you go to learn.msb.com, we have a whole self-paced learning environment with a lot of content there. That's actually going to be open sourced soon, but yeah, send me an email or whatever you want. Let's go back to our example here. So we can see that the pods are responding back. It's all good. If you could have a look at my screen right now, I just want to show you one problem. So I'm going to do kubectl scale. You don't have to follow along. It's important that you understand what's happening here. I'm just going to increase the number of replicas to 6 right now. So if you remember, as we were scaling and doing things before and running these requests, everything was working great. And the reason for it is because the pods started up very quickly and they were immediately serving requests. Let's see what happened now. So I'm scaling it up. It's pulling images, all good. But you can see now as I'm doing requests, basically half of my requests will be failing, you see now, for 10 seconds. And this is not a good situation for us to be in. Now it's back to normal after 10 seconds. But this is a very common scenario where, if you imagine from a Kubernetes perspective, the supervisor is running on there, it sees the process is running, it's just not doing anything useful, but Kubernetes cannot know about that. So every time, I'm just going to go back to the situation where you are. So every time we did this kind of, any kind of manipulation, the cluster basically a certain number or all the requests would fail for 10 or so seconds. This is obviously not a good situation to be in, and this is not very good engineering. I have worked in a few places where this could be good enough, but that's a different story. Let's just try to think how to fix this. So let's do the same thing we did before. So this will be an even worse situation. So let's take in our deployment delay.yaml and change it to version 2.0 and see what will happen now. Let's change it to 2.0 and apply it. And then I'll be doing these requests and we'll see what's happening there. So here now, it's even worse. So for 10 seconds, basically, our whole infrastructure is down. The older pods were in a terminating state. The new ones have started. The Kubernetes thinks they're ready, but for 10 seconds, we lost all the traffic in our service. And this is a very bad situation to be in. Is everybody following along to what's been going on so far? Okay, I'm getting a few yeses. I've never yet received any reply to curl delayed. Okay, that's very good. T said, let's troubleshoot this issue. So as you remember, you can curl the delayed service. If we do curl delayed, sorry. Now it's not working, and it should be. Can anybody tell me, I'm going to, so what we did right now is we just manually exposed it. So before we specified a nice version manual through a YAML file, but now we just did an expose function. So can anybody maybe have a look at this specification and think why curl doesn't work? Yes, Liam is right. Basically, Aaron says local IP. No, it's working well. The problem is, if you do a curl, it goes directly to port 80, right? Yeah, Tim is right also. So if we want to use curl delayed, we have to use port 8888, because if we just use the basic expose command, it just copies whatever the pods are listening on. So I hope, who was it? T, I think. This makes sense. So curl delayed 8888, because it's not listening on port 80. But what a service is just this combination of magic IP and a port. If you route traffic to there, it's going to magically go to a port. But very good question. Thank you. So we did the rolling update. Everything was failing for 10 seconds. Very bad situation. How to fix it? So what will be? Okay, Martin also has to leave. I'm glad you had fun, and just ping us Twitter, email, wherever you want. Thank you for joining. What we'll be doing now is introduce this kind of small concept of Kubernetes called a readiness probe. And what it does is basically, it doesn't allow a pod to be ready until it actually, the probe, as the name suggests, returns a success. So let's delete this deployment, simply to kind of get rid of the replica sets. And let's also change the version back to 1.0. It's not super important, but it's easier. So let's change the version to 1.0, and we will be now editing our service to add this thing called a readiness probe. Let's just have a look at the readiness probe quickly. So it's a readiness probe of a type HTTP GET, which means, and we're going to configure it by saying route to path just root on port 8888. Initial delay seconds is 5, which means wait for 5 seconds until you make a first HTTP GET request. Period seconds, every 5 seconds repeat the period, every 5 seconds ping. And success threshold is how many 200s or HTTP OKs you have to get in a row for it to be considered a success. In our case, only one. So what we'll be doing now is adding it on the container level because it's a probe on the container itself, right? So let's just add it to our configuration. If you're not used to dealing with YAML, this takes two spaces to input. If you're not used to and are having problems, there's a deployment full which contains the solution to this that you can just use from this point on. But let's really try to manually add it. So on the container level, I'm just going to add it below the image. Readiness probe of type HTTP GET path root port 8888. Initial delay seconds. I'm going to put 3 period seconds 3 and success threshold, which I always misspell, 1. So what this will do is it won't allow a pod to be ready until the actual probe goes through. So the simplest one are the HTTP type probes, which are used for this kind of health Z endpoints. But you can do actual bash commands or whatever you want to run for a more complicated scenarios. But the idea is the pod will not go in a ready state until it's actually ready. So let's deploy our new deployment, which now has a readiness probe in one of its containers. So we're working deployment delayed.yaml. So if you look at the screen, like what happened now, immediately the pods went kind of bluish, which means they're ready inside of how we represent stuff. But now we can see these events readiness probes are failing. And after 10 seconds, okay, now they're ready to serve traffic. If we try to actually route traffic to it before, we would just say, hey, there are no pods ready to reply. So, okay, yeah, we created it. So before, if you remember, let's scale it up. If you want to make a request to see things are working, it's all good. So let's scale it up. When I did it before, you notice that a lot of my requests were, I doubled it, so half of my requests were failing. In this case, a quarter of our requests should fail. So let's scale it up and quickly send a lot of, try to send a lot of requests. And if you see now, no requests are failing, simply because the pod is not marked as ready. And until it is, the traffic will not be routed to it. And now that it is, I think this is the one. Yeah, it just responded to our request. So just with this simple tweak, we resolved the situation. We'll be doing now a rolling update soon. But there are two things that I would like you to kind of notice here. First is how hard this would be to do without Kubernetes. Obviously, it's doable, but you would have to do a lot of work manually to do so, or like deploying 2 a.m. when nobody is doing anything. And the second thing that is very important to kind of stress out is a lot of frustration from what I see. We've been teaching Kubernetes a lot comes from, people coming in, they learn just enough Kubernetes to be able to do what they did before, these kind of old-ish patterns. And then they get frustrated, like, this is way too complex. I don't need all these things. I just want a Docker kind of thing running. And that's a very valid point. But the whole point is, the more you know Kubernetes, if you just learn just enough Kubernetes to kind of get by, you're not getting all these kind of nice things that are coming to you out of the box. So the more you learn, the more kind of powerful it gets. And like, I see it over and over. They just learn the basic deployment, basic pod, basic service, and they do a lot of the work that I did before. They're not using any of the benefits that they're getting from Kubernetes, and they're all very frustrated. Like, why do we have to do all these weird YAML files? We're not getting any benefit. So kind of the more, like, obviously we're incentivized we're a Kubernetes training platform, so, but I really do believe that kind of Kubernetes is a kind of distillation of a lot of these best practices, and a lot is available out of the box if you just know where to look. Aaron asks, is there a good strategy to get the numbers for readiness probe for a production system? I mean, it depends on your system, obviously, I don't know. So usually, you know, there's a lot of these health Z libraries. So usually you would have an HTTP endpoint on your service /health Z, which is a standard kind of way for the service to report is it healthy or not. So like there's a readiness probe, there's also a liveness probe that will constantly be pinging, are you alive, are you alive, are you alive? So good numbers, I don't know, at least a few requests, I would put the success threshold 2, 3, 4, and then you should be good. But I don't know, if you're working in a bank or a e-commerce store selling vases. Okay, let's do the thing that we did before. Let's do a rolling update, change the image version. So it was 1.0, let's change it to 2.0 or the other way around, it doesn't really matter. We want to trigger a rolling update. So let's change the image version and do the kubectl apply. As we are now running requests, before for 10 seconds everything was failing, but now we're good. The system is actually waiting for things to be ready, and as soon as they are ready, the system is responding, and we have a smooth transition to a newer version. One thing that I didn't talk about much, but you had an opportunity to see now, is this concept of, you can see the rolling update strategy we had here. You can these two things specify how quick the rolling update actually happens. So max and available means, I don't know, how quickly or how slowly the old ones will be shutting down, and max surge means how quickly the new ones will be wrapping up, scaling up. So you can have like a very slow, gradual transition, or you can quickly shut down new ones and shut down the old ones and increase the new ones, and just by changing these two configurations. One other thing that maybe just quickly, we're way out of time, is if you noticed, so usually I would ask a question, if you notice we had 4 replicas before, now we only have 3. And what happened is the YAML file is the important one, so it actually overrode the configuration inside of the running deployment. We did a lot of the scale operations, and you really should not be doing that. Obviously, you have to know how to do it. If something is on fire, you have to go in and fix it. But it's very dangerous to do a lot of these manual exposes or manual scaling, because the difference between your YAMLs files and your actual system will start to kind of diverge. And you might have a few of these quick fixes that you did, and if somebody's trying to replicate the system, they're simply not there anymore. So usually whatever you do, like change your YAML files and then push it to your cluster, ideally through a CI/CD system that actually applies these things to have like a nice production system. So try to keep the manual kind of operations to the minimum. And thank you for following along. We're a bit over schedule, but I hope you liked it. This has been a small part of our kind of full internal DevOps bootcamp that we do, where we're like digging deeper into these processes. If you like, just send us an email at hi@msb.com or on Twitter on Magic Sandbox. And I think Joe would also like to thank you guys, but I'm sorry for being a bit over schedule, but I hope you enjoyed this.
Thank you, Mislav. I don't think I've got video on just yet. Could we get this on?
I can try making you a host. I think that will work.
Yeah, I think that will work.
I'm getting very good confidence. Thank you very much.
Perfect. You can see me. Thank you very much, Mislav. It was fantastic. Very unique session today. Sorry for those that couldn't see me to begin with. I hope you all enjoyed it. Don't forget to follow us on LinkedIn afterwards as well. We'll be sending about a feedback form. So if you want to drop down some feedback around, you know, what we can do next around kind of lockdown learning sessions, what you want to hear about, what you liked about this particular webinar with Magic Sandbox, Jordan, Mislav, that'd be great to hear your feedback. And enjoy the rest of your evening, guys. Thank you very much.